Hey everybody, as mentioned, I'm Hunter and I'm here from the government, here to help hopefully. So today's talk is going to be about how we use Python in the city of Los Angeles, kind of give an overview, and then a particular case study involving mobility data, including using some machine vision stuff that we've been doing, and also some data specification stuff with scooters. Get into the case studies, but just give a little sense of my totally transparent secret motive for this talk is we are going to have to hire about 500 to 1,000 technical roles in the city of Los Angeles in the next 3 to 5 years due to retirement, and every government is pretty much going through this same thing where we need to hire a ton of people who understand how to use technology. So I want you to consider a career in public service. So this is my totally transparent motive. So I always find it helpful to give you a little sense of who am I and how did I get here? Before I worked for the city, I worked for the Center for Data Science and Public Policy and the Data Science for Social Good Fellowship at the University of Chicago. And I'm super active in our my old local civic hacking group, which was Shy Hack Night. And if you're here in LA, Hack for LA, they're both affiliated part of the Code for America Brigades program. So if you want to get involved in civic technology and civic hacking and you're I don't necessarily know if I want to work full-time for the government, please, I encourage you to check out Hack for LA, or if you go to Code for America, you can actually see whichever one is local to your jurisdiction. But Hack for LA has hack nights on the west side and east side working on civic technology programs, help make LA a better place. So this is Los Angeles. You probably knew that. This is what you might not know. So we have about 4 million residents in the city of LA. We service about 65,000 miles of streets. LA has the largest street network of any city in the United States. This is a continual source of hassle and trouble for us. You may have heard of this thing called traffic that our constituents don't love. We're trying to fix it. It's hard. We receive about 700,000 service requests a year. Who of you have filed a 311 service request? All right. I'm going to pick on one of you. What did you file a 311 request for? Dead tree. Yeah, so we will clean up dead trees. What did you file a 311 request for? Bulky item pickup. So that's our biggest driver. We will pick up a bulky item anywhere in the city of Los Angeles within 48 hours, and we do that regularly. So this is a huge operation. There are hundreds of people who work on this, and making sure that goes out on time. There are technical roles. They're huge. They're physically, you actually have to pick it up. There's disposal. There's environmental concerns. There's we can talk about our sewer network. The city is huge. So how do you start to think about measuring it? So the way we split in our internal data group, how we think about the city is, are we talking about a policy or are we talking about an operation? So as I mentioned, 311 service requests, that's an example of an operation. We physically go out and do things constantly, 700,000 plus times a year. So a policy is something where we're actually making something you might know as the law, or what I like to call government code, the LA Municipal Code. So we joke, our job is to turn computer code into government code. So stuff might be a traffic demand management policy. There's all these sort of levers where the government has a huge amount of influence on how the built environment is being built and the world you live in. And we often have no data when we're starting this process. So it's how do we actually use data to make sure that our traffic demand policies aren't just a thing that we have that exists, but are a thing that we have that exists that is helping reduce traffic in the city of LA. So you might have an operation like port to runtimes, we have port emission standards. The city is really an A to Z shop. We have everything from the airport to the zoo. So this big question, linking our policy and operations to outcomes, because the idea here is let's do government in a way that makes sense. And I promise this is going to get technical very quickly, but I wanted to give you a high-level overview of why is it important to do good programming and good data science in government. So rigorous measurement and testing, this sounds this is fairly radical when it comes to government, and the idea of hey, we can actually measure and test whether a policy is working, and we can do it a lot quicker than we used to be able to. So let's give some examples of that, because that was kind of this very theoretical thing. So nobody likes paying taxes, but it's the law. And we have a team of about 45 people in the city who audit businesses. So the thing is they can only audit about 0.5% of the businesses in Los Angeles we have every year. So we worked with them to build a predictive model of which businesses we should audit. This resulted in a quadrupling of the successful audit rate. So instead of every 1 in 10 businesses that we audited actually resulting in us finding somebody who was cheating on their taxes, we're now at about 50%. So that's been a huge, internal win for us. This means like, hey, your tax dollars are being better spent. Businesses that are, don't need to be audited are not getting audited, and businesses that have been likely to, have previously not paid their taxes are now being audited. Who has heard of the Ellis Act? Anybody? There we go. Who lives in an apartment in Los Angeles? Who lives in a rent-controlled apartment in Los Angeles? So for those of you who live in rent-controlled apartments, that's a huge percentage of our city's residents. I think it's about 30% of the city lives in rent-controlled apartments. These are apartments that are built before the 75s. However, there is a state law called the Ellis Act that allows a landlord to evict everybody in their apartment and then convert it into condos. However, there's a whole bunch of terms and conditions associated with the Ellis Act. Like there's all sorts of fees associated with it. There's rent, you have to pay rent for any tenants you might want Ellis Act evasions. So unscrupulous landlords have a habit of telling their tenants, I'm Ellis Acting this building, you have to move. And they don't actually tell us, the government, that they have to file this Ellis Act with, which means that the tenants don't get the benefits that they're entitled to under the law in a building that is Ellis Acted. So we have an outreach team, about 100 people who work in our housing and community investment department I think that team speaks no fewer than 7 different languages. And they need to know which buildings and which neighborhoods should I be going to where there's likely to be an Ellis Act. So again, they don't have enough resources to go to every building in Los Angeles every year. There's about 250 of these a year. So we were able to use Scikit-learn, Pandas, pretty basic machine learning tools, to predict which buildings are likely to be Ellis Acted. And then we hand that list over to our outreach teams who are able to go to the buildings and provide information about like what you're entitled to as a renter. And that has resulted in that we are actually out in front of this problem. So instead of people already being evicted and already like sort of being past the point of recourse, they actually know who to call when an Ellis Act is being filed so that they can get access to the proper resources. We worked, again, in housing. How many databases do people think the city of Los Angeles has? Individual SQL databases. Any guesses? 10,000, okay. Anybody else? All right, so we have about 2,000 databases. It's a little smaller than that, but still in that order of magnitude. So somewhat obviously, some of these databases are describing the same thing. One of the biggest areas where we face a problem is we have like about 15 different databases that solely describe which type of affordable housing is available in different parcels. So we were able to use Pandas and I highly recommend the dedupe library to dedupe all these databases and allow you to see an individual picture of, this is 1700 West Magnolia Boulevard, and you can see how many RSO units are, how many, you don't have to know what these acronyms are, but this used to take somebody 45 minutes to do one building, and now they can do it in about 3 seconds just using very simple open source tools. Another big project we're working on is earthquake early warning. So this is in partnership with the United States Geological Survey and Caltech. If you live in California, you are probably is everybody prepared for an earthquake? Everybody has a kit? Please nod and please go make a kit. In all seriousness, get prepared for an earthquake. There's all sorts of great resources available online and linked in this talk. But one of the things that's been super important for us is we've been investing a bunch of money along with the state of California and the federal government in what's called an earthquake early warning system. So these systems will give you 30 seconds to 2 minutes heads up of strong shaking likely to occur. It involves a predictive model that basically, as the ground starts rumbling, as you can see out here on the San Andreas Fault, the S wave and P wave take longer to travel. It's only traveling at the speed of sound through rock. So we can actually get a short warning, depending on how many sensors there are, anywhere between 30 seconds and 2 minutes of what is, is there shaking going to occur? And you're like, all right, Hunter, what can I do with 30 seconds to 2 minutes? So there are a lot of important things for people to do. Obviously, you can get prepared. If you're, in a, building, you can go, drop, cover, and hold on, all the sorts of things. But what's also important is that we prepare our machinery using to handle an earthquake. So one of the things we're working on doing is automatically raising fire doors. So it turns out if you shake a fire station really hard for 30 seconds, the rails that the door physically lifts on might slide off. This means that the fire truck that is responsible for responding to emergencies the second after an earthquake occurs might be stuck inside the building. So if we can raise those fire doors automatically before the earthquake hits, it's a huge win to make sure our public safety response times go up. So this is one thing we're working on. There's going to be an Innovate LA event focused on all the different earthquake early warning pilots going on in the city coming up next week, so search that online. So some things to be aware of when you start working with government data. So people often talk about bias in machine learning, right? There's a talk about model fairness. The bias is never coming from the machine learning in my line of work. It is always coming from inside of your data. The way we collect data is inherently biased. The processes in which the data is collected encode a form of bias. Any data scientists worth their salt, especially those of you who work on problems that are important to our public, as a civic institution, need to understand that your data is inherently biased, and you need to understand what you can and cannot use that data for. These are those trade-offs. Another thing that I believe very strongly about how government should do is your algorithms need to be interpretable. You can't have any black boxes. It's okay that I don't know how Amazon predicts which. I bought a trash can, it wants me to buy 6 more trash cans. It's a private company. But when you're working in the public trust and the public space, you can't have these black boxes. Working in the public sphere means working in the public interest. And this is, I think, really important for those of you who, work in fields that are adjacent. Maybe your firm does government contracting. Maybe your firm is doing something that serves a huge number of people, like in healthcare. All these sort of, working in the public interests, the public sphere means you should work in the public interest. This is the thing I feel strongly about this. And then another way is going back to my slide, the policy, when we make a policy, when we make a law, that becomes essentially an algorithm for the way we build our cities, our community, our state, our country. The algorithm becomes the operation. We have these 311 folks who pick up bulky items all the time, but if you live in different cities, they will not pick up bulky items as frequently, so your operations are different. And then your operations is fundamentally impact on people's lives. So that's sort of the theory of Python and data, at a government scale, what's important to us. I'm gonna dive down really low and focus on transportation and mobility for a little bit. So we have 2 little case studies here. Machine vision, there's a typo there, for pedestrian and bike counting. So this is our first case study. So what you've got here is a map of Waze traffic jams at 2 p.m. on a Friday afternoon from our Waze Connected Cities Partnership feed. The city has a ton of information about how people use automobiles to get around the city of Los Angeles, and all that information comes to us in an incredibly high fidelity, whether it's the Waze traffic jams feed, our AtSac system, which is a bunch of we have about 600 cameras around the city that help us monitor traffic conditions. We have what's called RITS. This is actually a regional system. If you've ever looked inside a street, have you ever seen a little black circle that kind of looks like a darker outline on asphalt? These are magnetic sensors that count how many cars are going through your highways and your major arterial roads constantly. Like Internet of Things, it was built for the '84 Olympics. It's an incredibly complex system. Kind of amazing that this thing exists. But we're getting data that's 24 hours a day, 7 days a week. So compare that to how we measure bicyclists and pedestrians. This is a spreadsheet that is the result of somebody sitting at a corner and counting how many bicyclists and how many pedestrians walked by. So, there's this manual process. Yet, when we go to talk about these projects, we compare these 2 data sets. And any analyst should be able to say, hey, that's maybe not a great idea. If we have data with this incredibly high fidelity, 24 hours a day, 7 days a week, we're going to have much more granular data than this one person sat on a corner for 1 day that could be influenced by all sorts of things. What was the weather that day? Were there any special events, et cetera, et cetera? So if you're Santa Monica, what you do to fix this problem is you actually buy pedestrian and bike counters. These are physical things, you can see that. Santa Monica has about 35 miles of major arterial road. I have about 3,000. So it's cost prohibitive for the city of LA to do what Santa Monica did. But we have all these cameras on almost all of our major arterial roads. So, we were like, all right, let's think about, how can we use machine vision's a thing? Like, we can probably detect that. So we're like, Google, they've got some really good machine vision technology. Let's go see how good they are at using our ATSEC cameras to detect if there's a pedestrian in that image. Google has an incredible algorithm. This is like off-the-shelf, like pre-built AI for you. It's very good at telling me I'm looking at a road. It's very good. This is a mode of transport. It's a lane. It's some infrastructure. I really love 68% probability that you're looking at some infrastructure. What does that mean? That's like, anyways, so because this algorithm was pre-built for the purpose of general purpose image classification, it wasn't actually very good at the thing we wanted to do, which was people and bike recognition. So working with Cal State University Los Angeles' Data Science Research Lab, they are awesome. They built a customized algorithm that we still deploy on AWS, still on the cloud, but is trained just specifically to recognize pedestrians and cyclists. And furthermore, it's not trained to recognize faces at all. It is just recognizing the counts. All we get from this system is there's one person. This is down in Little Tokyo. It's first in Alameda. 2 people walking by. I don't know if that person then went to I don't want to know if that person then showed up in another camera over there. That's like a violation of civil liberties. We don't want to cause that. It uses our existing infrastructure. So even when you've got really janky old technology, these are like 1990s grade analog cameras. We have an analog to digital converter inside the central control room that we use to pipe this stuff to the cloud. These cameras shake because when somebody drives a truck by one of these poles, it starts shaking the camera. So there's all these sort of issues you have to deal with to get at these counts. But that's incredibly powerful because now I can say, going across the First and Mission Street Bridge, and it's not really me who's saying this, but other folks from our Department of Transportation and our policymakers can now say, okay, we had this many bikes, this many pedestrians, this many people in buses, and this many people driving. And that way we can actually tie any of these policies when we change the road infrastructure to what actually changed the mode share infrastructure. So, people say counting is easy, right? Counting is hard. This is 2 years worth of work on just getting better at counting. So that's first case study. I'm gonna pause really quickly. I'm gonna push Q&A towards the end and just kind of field all these questions rapid fire. But who of you has seen a scooter or shared dockless e-bike in their time in LA? Who of you has ridden one? Hands can stay up. Do you like riding them? No, we got some no's, we got some yeses. Who of you are not from, so for the folks who are not from LA, we've seen a proliferation of these companies. There's now 4 or 5 companies providing dockless scooters and e-bikes around sort of a disruption in what we call the mobility marketplace. So to frame this, LA is experiencing a disruption across the mobility market, and this is not just the scooters. You may remember when this happened. This was kind of eye-opening to local governments, which is companies cab markets as a marketplace had been very static. And now this is streets in which Uber drivers, an Uber heat map from spring 2016. So we've launched an EV car sharing program in low-income neighborhoods. We now have all these scooters and bikes. Half of these companies have left the US market. We have people talking about building tunnels. So how do we manage this process? So, especially with sort of an eye on the future of look, we're going to have autonomous vehicles. People say we're going to have drones. And this is the thorny technical problem. How do you support a city with hundreds of thousands of different shared autonomous devices in hundreds of different cities with a near infinite supply of edge cases? Does anybody know how many cities there are in LA County alone? There are 88 cities in LA County, plus unincorporated county. So just in LA County, there are 89 sets of different traffic laws. Now, a lot of that is standardized, right? Like, no matter which city you're driving in, a red light means a red light. A stop sign means a stop sign. Lane markings mean lane markings, you know? But so what we've been thinking about is, what's the digital version of that? So we went, this is like fairly radical for government, but we went on and we made something we call the mobility data specification. So the mobility data specification is a set of APIs that allow us to manage and control mobility devices, autonomous mobility devices, starting specifically with scooters and dockless bike share. You see we've had contributions, City of Santa Monica, we've had the City of San Francisco, Seattle, Austin, and the companies themselves have been contributing to the specification. It is completely open source. We're using semantic versioning. We've got about we released the 0.2 version a little bit while ago. But what we give is a set of APIs that allow you to do a stop sign, but digitally, and understand trips digitally. So any company that operates in the city of Los Angeles as part of getting their full conditional use and full permit for a permitting process, which you don't need to care about, has to build what we call the provider API. Additionally, in the city of LA, we're building something called the agency API. So the way to think about this is the provider API looks backwards, lets us describe operations about what's been going on with these companies. Agency API looks forward, about handling things like license and registration, handling things such as permitting, updating telemetry, warning users if you're about to go into a construction zone. All of that functionality can be exposed. Again, what we're not trying to do is launch our own app that like competes with these mobility providers. Like we want them to do what they do best. What we want to do is support having the data available to us so you can see, regardless of which city you're in, it doesn't matter if it's Santa Monica or LA. It looks seamless to the end user. So the data that we get, we have this idea of, instead of asking, traditionally when governments do permitting programs like this, like when we permit taxi cabs, when we permit anything, we'll ask like, tell me what percentage, the data that we ask for generally is like, on a quarterly basis, please give me a floppy disk full of what percentage of your customers were low income. This is like the wrong way to do this thing. The way to do this so it actually works in real time is like, think about what are the atomic and small data models you need to create for these devices. So we basically create two. One is a status change. This is a representing of something reserving or not reserving the curb. And then we have trips. This is fairly self-explanatory. One important thing about this is there is no personally identifiable information in this data set. We don't ask for like which user is making the trip. We just want to know, did you put a scooter on that curb so that we can make sure that it's not in the handicap zone. So there's a huge, now like 6 or 7 different open source repos, aside from some companies offering this available to you. We have a bunch of open source projects available to help load this. We have our Airflow-based ingestion tool of the city of LA. Santa Monica is building their own separate tools. But essentially, we have a provider API. We pull that data into AWS, and then we use that for our reporting functions, our monitoring and compliance functions. So for example, in the city of LA, we advise that you don't leave a scooter on the corner for more than 24 hours. So as part of this, as this is being set up, every time a scooter has been existing on a curb for 24 hours, we send an automated email to that company. If we receive one of those 311 service requests to remove it, we then route that to the proper company. All sorts of really interesting, like hard matching and data problems going on in the back end there. We also do a lot of really interesting validation of this using JSON schema. So going back to this like, okay, you have hundreds of cities, dozens of companies, you can't validate this by hand. Like you can't have, well, company A describes a trip like this, and company B describes a trip like this. So we use JSON schema to automate our validation. And then we have an agency API, which is what the companies use to access information about us, like if they want to register a new vehicle so that we can keep them inside their CAP compliance numbers. If they want to rent a vehicle, there's different endpoints available there. And there's going to be a developer portal that they can access. So that's what's coming in the future. I'm going to skip this section of like how measuring the caps about moving devices is kind of hard. If you want to ask me about that, there's some code online you can take a look at. Because I want to get to the point of, if you're interested in all these sort of problems, if you want to help solve the future of mobility, if you want to talk about healthcare, there are tons of jobs available in government. And I want you to consider a career in public service. So here are some local links. There's our personnel site, LA County also hiring a ton, Metro. There's work in the federal government. Every one of us needs to hire. So really, I encourage you to go out and apply. But this is sort of a whirlwind tour of how we use Python at the City of LA. And I think I'm going to open it up to Q&A.
All right, so yeah, I'll be roaming around with the mic if anybody has any questions.
Hi. What's been the biggest adjustment for you working within a city government?
I think the biggest adjustment is adjusting your timescale. If you come from a private environment, there's typically the number of people you need to buy off, the expectation of how quickly things should exist. City government doesn't stop existing. No government stops existing. The city of LA has been around for longer than this country has. Some of the data sources that I work with daily, like our parcels data file, have relics of the Spanish land grant program that started when, this was part of the Spanish, this area was part of the Spanish Empire. So the way you plan things is pretty much in a yearly cycle. So working from where things might have been planned in a quarterly or sprint cycle, and you can bring those into the way you actually build your stuff. But in terms of your long-term planning, that time horizon is just completely blown open to me.
Are you guys planning for the Olympics? And if you are, how's that headache going?
We are. There's a whole office of Olympic folks who are hired just to start getting prepared for the Olympics as well. I'm not particularly involved with that project. I suspect as it gets closer, they will start to ask more questions around data and stuff, and then that tends to be when I show up.
How come we can't get a train to the airport?
We are. It's being built. You can go see the construction site right now. Again, government is a participatory process, and, I think now we're getting to the point where there's, enough will to build a train to the airport, but there was not necessarily, 45 years ago, there was not necessarily the will to do that. And then, honestly, it just takes time. There's a lot of trade-offs involved in constructing something in some place you could build a train to the airport a lot quicker if you said, we're just going to demolish LAX and then build a train and then rebuild the airport, and it's going to be closed for 2 years. But I think every one of you would say off with his head immediately after that. So, the challenges of, we're building the bicycle, we're building the train, we're riding it constantly. Because the city, as I said, it doesn't stop. So that's one of the reasons some things take longer than they might as certain disruptors say, well, if I just start digging a tunnel, you might also hit a, gas pipeline and, blow up a large city block, which is, there's a reason we do this stuff slowly, because we need to do it right.
It's a really intriguing policy decision to essentially force companies to interact with an API to provide service to their customers, which are members of the community. That paradigm's incredibly interesting. Did you have any precedent, or what led you to propose that as a solution as a very programmatic and mandated API interaction between private company and public interest?
Right, so the legal justification that our attorneys can tell you is they are putting stuff in the public right-of-way, and it is our legal responsibility to manage the public right-of-way as California Vehicle Code and Government Code. I cannot cite the numbers for you, but that's what the attorneys will say. Why we decided doing an API instead of the traditional method is we can't scale these using I get an annual report about the scooters, and I'm if people are complaining about, there's one in the Venice Canal, they don't want to know in our annual report, oh, we only saw 3% of scooters, had problems. They want us to say, okay, we're working on it, we're going to issue a ticket, it will be gone within 48 hours. And the way we do that is via an API, or sets of APIs, really.
Hunter, I'm curious how rooted you think the type of data science you're bringing to the city is in like the institution. Like, say if later today you were hit by a bus,
My bus factor?
or even worse for you, I'm sure one of Elon's self-driving cars. If you were hit by one and you were gone, would the work you're doing at the city survive? Is it integrated into the institutions yet, or is it still kind of grafted on top?
Is it perfect? No. Are we getting there? Yes. So right now, there is a dedicated city budget line item for a citywide data science and predictive analytics team. We are growing. When I started, it was grafted on. Like, I was one person. We're now going to be 4 by the end of this fiscal year. We'll hopefully be more the year after that. And if you know something about city budget line items, they don't tend to go away. So I'm really hopeful that, it takes time to do this, but I'm pretty optimistic that we're going to have really rooted a strong analysis culture in the city.
So I used to work for Freddie Mac, which is like a large oil, and I was like, I know all of these problems. These are the transparent model stuff and all that kind of thing. And I always found the problem was like I'd go into a room and be like, hey, we should have an API for this, and just like no one understood what I was talking about. So even like in a financial firm, which was technically literate, they were incredibly technically illiterate. And I'm just wondering sort of like how do you approach the whole framework in a community that is not necessarily.
Yeah, so APIs are good, and why do we all think APIs are good? We all think APIs are good because it enables us to do all these interesting sort of things on top of it, like I can access the data quicker, therefore I can build these models quicker, and therefore like Freddie Mac is more stable, more profitable, more able to achieve its end goals. So notice the reason like I exist is like because there are like senior leadership in the city who believes our policy and operations can be better informed with data. So I don't say like, hey, we need an API. I say, hey, the overall goal of this project is fix our street sweeping routes, identify who is at risk of being evicted. And then I'm like, okay, in order to do this well, we need an API. Like this is a thing we now need to do the thing you want. Then it sort of solves that chicken and an egg problem. I don't know if it's a perfect answer, and it fails a lot, but it works some of the time. So that's good enough for me.
Hi, I'm sure you have hundreds of data problems on only one of you. How do you prioritize which is the most pressing need?
There's this thing called the city council and the mayor, and they tend to very quickly tell you what the major problems in the city are. And they have this thing called a budget letter, and it's like a very internal document where they tell you what the priorities are for the year, and then they also make laws. So yeah, we have leadership. It's not to say it's not my problem, but it is decided at a level above my head.
Thanks for this talk. This is pretty awesome. So I'm from Seattle, and there's a Seattle Open Data Portal where we can explore as, citizens of Seattle, like the data sets that are available. Do you have an equivalent thing for
Yes,
LA?
not actually. So there's another city team that manages open data. So we have both data.la. I linked it on the bottom of my slide, and I was kind of ramming through this talk real quick so we could get to Q&A. But yeah, so data.la city and geohub.la city for all your geographic and open data needs. And again, open data also gets, actually the biggest users of open data sites tend to be internal users because, I can now get data that describes things I'm doing but wasn't in my department actually tends to be a huge thing. So I use those sites daily.
I was interested by the requirement of interpretable models as it relates to the business tax fraud detection. Like, is that model kept confidential or something? It seems
so
like
the data is obviously kept confidential because I'm not going to go put your data. But the model is available online. If you had simulated fake data that is of similar distributions, you could see how we arrived at this model. But you can follow, again, it's just Pandas, Scikit learn, and a random forest. It's not the most revolutionary. It is really not revolutionary technologies, but you can still do a lot of good with not. You don't have to deep learn or blockchain your way to social good. You can clean up some data and figure out how to make somebody's life 80% easier and solve a lot of problems.
So many of your problems, I'm sure, are problems that every city or many cities in America are trying to solve. To what extent have you worked with other cities to try to collaborate and figure out what have they solved already?
Yeah, so that's like this huge, if in the like broader like civic technology, public interest technology, government data, whatever this community that like we're kind of a part of is called, is kind of this huge thing that we've had trouble solving. I think with the mobility data specification, because it was a new area, we were able to work really closely with a lot of other cities, because like we're not the only ones facing an onslaught of scooter and bikes, and like those who are also trying to like manage it and grow it and not just say, like there are a lot of cities that just said no. Or okay, if you're New York, like New York's policies around scooters and bikes is, okay, you can put 200 of them in the Rockaways and that's it. So like when you're actually trying to like manage these things, like the cities that have been trying to do that we've been in sort of this participatory process with GitHub and open source. There are also networks of folks, so there's like the Chief Data Officer Network, so our city's Chief Data Officer participates in that, and she brings back a lot of technologies from other cities and best practices. There's all sorts of like, there are entire conferences solely dedicated to government technology, if you really, want to wonk out. But I still think it's kind of an unsolved problem of like, the other problem that kind of is like, every city is just a little bit different, which means their data collection process is just a little bit different. And this was one of the key things we realized with the scooter data was like, we have an opportunity, because this is a new area, to make everything at least look the same, even if all of our policy goals are different, the data is the same. But if you're talking about every city's financial tax collection systems, there are a lot of Oracle databases, all with different schemas.
If there are folks in the room or have friends who are interested in getting jobs as public servants, do you have a high level, any like warnings or advice for them in navigating the process, where to go for help on that? Because I hear it's quite different than industry hiring.
Yeah, so getting hired in government takes time. The trade-off to this is like, you get a pension and you get like pretty much a career track that will like, there are 50,000 people who work in the city of LA, there are 100,000 who work at the county. Like, you keep promoting like inside this system because it is a small city worth of people who work for the government, just in our county alone. I'm sure plenty of us grew up in places that are less than 150,000 people. So it takes time to break in. But once you're in, you can work, it's like work your way up. So that's the way the system is currently designed. I don't really have any comments on like, is this good or bad? But fundamentally, like, throw in your application as soon as possible and just prepare to like, don't have to do anything, wait around. Then you have to do a lot of things 1 week, and then you just wait around a long time again. For at least like full-time civil service jobs. That being said, there are a huge array of like government adjacent and civil service adjacent stuff, whether that's being hired into an elected's office or being hired at a university to do research on civic data or being hired at a company like Fair & Peers that does a ton of consulting for the government that hire on like a more normal schedule if you are actually looking to change your job right now. And it's very typical for people to sort of take that as an intermediary step to like a full civil service career. It is how I got started. I was in a research lab, then I was contracting, now I'm full-time civil service.
I know you mentioned like Hack for LA. How easy is it for like a person that wants to contribute? I'm a software engineer, not a data scientist, but to contribute to like a project that's actually being worked on rather than just saying Hack for LA is like, oh, this is a cool project that someone maybe not as experienced might be interested in, like just getting their hands wet versus someone that's really just like, I just want to help the city. It's like how does the city involve those people, or do they?
Again, it's sort of a mixed bag. I think there's a lot of trying, but there's also, volunteer efforts are not people who are working on full time. There is a need, there's a lot of really great sort of more activism-y projects that are going on in Hack for LA, and that's sort of where their strong suit is, and like where your strong suit as like a software engineer might be is like, you can do a lot. To speak to like a Shy Hack Night example, one of the sites that I remember being built at Shy Hack Night was mybuildingdoesn'trecycle.com. And so the city of Chicago had like this long problem with like different apartment owners. They're supposed to recycle, they didn't recycle, it was hard to report it. Like this site made it abundantly clear, resulted in a change in the policy that then resulted in a change in the operation and the way your registration of businesses that are landlords needed to go in the city of Chicago to ensure recycling. So this like over the course of a year, like an activist website changed the city council's policy, which then changed like the operating departments, like actual people who like are IT people or website people to change their website to make sure that the policy reflects, the operation reflects the policy. So that's sort of where I think the strong suit for like civic technology groups are, especially volunteer-led ones. And Hack for LA has a ton of projects like that that you can get involved with any Monday night on the west side and Tuesday nights downtown. Check out their website.
How hard is it to like shift your priorities when city council or mayor changes?
I haven't lived through a change yet, so in terms of my operation, you know, I don't know yet. In terms of like overall city, you know, again, a lot of the times, so much of our responsibilities are pretty, you know, it doesn't matter who's the mayor, who's the council, like you still want your garbage picked up. You still want your, you know, 311 request fields. People still need, like, the traffic signals need to go on every day. So, you know, the leadership definitely changes, but the bulk of city operations are pretty static.
I think we've got time for one or two more questions, if anyone's...
So real quick, I wanted to tie up with the previous one about Hack for LA. There's a number of these groups in different cities. San Diego's got one, San Mateo's got one. If your city doesn't, feel free to start one. At scale, we'll actually have a booth for those communities, and we're actually looking to do a track at scale, so talk to me if you'd like to participate in helping to make a track for like a day at scale and work with the Hack for LA guys. Thanks.
I'm starting a dangerous scooter gang called the Sons of Auxiliary Power, and we're going to collect up all of the scooters and charge them for the money that the companies pay. Can I publicly hit your API 100,000 times a second?
So the answer is these are the API. I don't, as there was an architecture diagram slide that I have lost. My laptop's out of battery. But essentially is the APIs that we're working with solely govern the relationship between the companies like Bird and Lime and Uber and Lyft and the city. They are authenticated each way. This is not a publicly, if you want to talk about like GBFS and like the publicly available stuff, that's a different universe. And that's governed by NABSA, which is the National Association of Bike Share something. North American Bike Sharing Association, there we go. But so we don't really touch that because again, this is about what our tools need to be to manage the public right of way and not necessarily like getting involved in the company's operations. I'll be here for another few minutes and then I'm like easily findable on the internet if you have any questions. And like on a last note, if you find this interesting, if this is eye-opening, like poke around the internet and highly get involved. Government is what you make out of it.